Let's start with our two basic kinematic equations. The displacement one, where we have average velocity times time equals displacement, and our final velocity is equal to original velocity plus a times time. And we can combine these two equations three different ways to come up with three new equations that are usable. I want to show you this so that you know where these things come from, but you won't need to be able to reconstruct this anytime soon, although later in the class we might do a few exercises along these lines. Also, it's a big deal when you get to college. Let's start out by getting rid of VF. So we have a VF here and we have a VF here, and what we're going to do is we're going to take this entire expression and substitute it in for that VF there to eliminate it from the equation. So let's build the no VF equation, and when we do that, what I'm going to do is, instead of writing a VF there, I'm just going to leave a space, and I'm going to put in a different color here. Let's do red. VO plus AT. Alright, so instead of writing VF, I wrote the other side of this equation, VO plus AT, in the space where we had VF. And now I don't have any VF in this equation. Now this is not a very friendly equation to use, so let's do a little bit of algebra to clean it up. We have a VO here and another VO here, so that's two VOs. So that's two VOs. And we still have an A times the time, and it's still all over a 2, and there's still a T out here, and we're just going to leave that S on the other side there. Now, another thing that we can do to help clean this up a little bit is to distribute this T to both terms. So we're going to have 2 VO times T plus A, and we'll have a T times a T, so that'll be a T squared, and all of that is over 2. And the S goes along for the ride. Now there's one more step that we can do, because nobody writes the equation this way. What we do is we distribute the 2 now to both terms, and that gets rid of this 2 here and limits our 2 on this side being 1/2. So S equals VOT plus, now this is AT squared over 2, which is the same thing as saying 1/2 AT squared. And this is a much more friendly and usable equation than the mess up there. And notice how it does not have any VF in it. This allows us to do a couple of things, like if you have a situation in which an object starts at rest, VO is 0, and anything times 0 is 0, so this entire term disappears. Or we could have a situation in which an object is not accelerating, which means A is 0. And again, this entire term, 1/2 times A times T squared, if the A is 0, that everything is 0. So this equation, as it is written right now, allows us to analyze several different situations, sometimes when VO is 0, sometimes when A is 0, sometimes when neither one is 0. All right, let's rearrange this guy by subtracting AT to the other side. So if we do minus AT and we do minus AT, then we're going to have VO all by itself, and then we have VF minus AT. And now we can build an equation in which there is no VO. So again, we have a VO over here, and we have a VO equals stuff over here. And what we can do is we can rewrite this equation again, just like we did last time, leave a space where I had VO, and instead this time I will, let's use blue, I will write in the VF minus VAT, VF minus AT in the space where I had VO. Now, just like last time, let's clean it up. We have a VF, we have a plus other VF. Go back to black. I think that's easier to see. So we have two VFs. This time we have a minus AT. All of it is still on top of a 2, and there's a T outside. And once again, we can distribute that 2 to both terms, that T to both terms. So now we have VF times T here, and we have a T squared for the other guy, and we still have everything over 2. And if we distribute that 2 to both terms, now we're going to have a VF times T minus 1/2 AT squared. Notice the big difference between these two equations. There's a plus, there's a minus. We started at VO, we ended at VF. And just like with the previous equation, this one is easier to use because now we can have a situation where an object is stopping. And if an object stops, that means its VF is 0. All right, one last change that we can make to that VF equals VO plus AT equation is, now, what if we solve for T instead? So what if instead we subtract VO over? So we have VF minus VO equals AT. And then we're going to divide everything by the acceleration. So we just have T equals VF minus VO. And you have to do that first and then divide by A. Well, we have a T over here and we have a T over here. So we can substitute to get rid of that T. And that will make us, that'll make for us a no T equation. That's not, that's no T. And we can rewrite our starting equation there. But now instead of writing a T, hey, come on out. I want to change color here. Let's do green. Now instead of writing T, we will write VF minus VO all over A. And then what we're going to do is clean this up, because once again, when we have a VF here and a VF here and a VO here and a VO over there, that's not a very friendly and usable equation. So since we're dividing everything by 2 here, how about we instead of divide, we multiply everything by 2, and the same thing for the A. We're dividing everything by A, so we will multiply everything by A on that side, and the fundamental rules of algebra are you can do whatever you want to both sides of the equation as long as you do the same thing to both sides of the equation. So we divided by 2, we multiply by 2, they cancel. Divided by A, multiply by A, they cancel, and they both reappear on the other side. So 2AS is equal to, and now I'm going to flip the order of VO and VF here for reasons that should become apparent in a moment. Now let's FOIL the right side. If you remember from algebra class, FOILing means you multiply the firsts. So VF times VF gets us VF squared. Then you multiply the outsides, VO, VF. Then you multiply the insides, and then you multiply the lasts. And you end up with VO squared with a minus sign there because one guy's plus and one guy's minus. And we've already taken care of the other side. They will just go along for the ride. Now it looks like we have some cross terms here, and this is extra ugly. It's not getting any better. But we have a minus VOVF and we have a plus VOVF. Those two guys are the same but opposites, so they cancel out and go to 0, which will make our equation considerably prettier once we get rid of them. And we just have the difference of 2 squares here. Now there's one more step for how I like to write this. I prefer to write this with VF all by itself, so I add the VO squared to both sides. Because it's a minus VO squared, we're going to do plus VO squared. We'll do plus VO squared onto this side, and then I mirror it so that I can have my variable that I'm solving for all by itself. This is just my personal preference for how I record this equation inside my brain. All right, and we have here three new equations. This one has no VF, this one has no VO, and this one has no T. These three equations, plus our two starting equations, the no A and the no S equations, are quite useful for analyzing different physical situations where all we're recording our distance, time, and speed, or acceleration, and to calculate the unknown. And if you again notice, there are 5 kinematic variables here. We have a VO, we have a VF, we have an S, we have a T, we have an A, and since we have 5 variables, if you take a look at each equation has 4 of the 5 variables. So S, A, VO, and VF, but missing 1. These 4 guys, but missing 1. What this means is, in any situation, you have to be given 3 of those variables, and then you can be asked to find the other 2. And what you need to do is, as you read through the situation, figure out which 3 you're given, and then how to get the other 2. And that's what we will be looking at in our next video with some example problems.